So this is number 2, quadratic functions and models, part 2. We are going to cover the modeling section of quadratic functions. So remember what a quadratic function actually is. You can write a quadratic function, f of x equal to, it's something that has x squared in it. So like x squared minus 2x minus 15. This is the function we're going to work with today. And we're going to start this section by solving quadratic, and it shouldn't say formulas here, it should actually say equations, so that's a typo. So solving quadratic equations. We are going to use the quadratic formula to do this, but we're going to start with quadratic equation. So a quadratic equation, this is a quadratic function, and a quadratic equation is basically you take the function and you set it equal to a number. In this case, we're going to typically set our function equal to 0. So we're basically looking for what are called roots. All right, so there are basically 3 ways to solve an equation like this by hand. You can factor it, and so we're going to do it that way. We can solve it by completing the square, which we talked about last time, completing a square. So we're going to do it with that method. And then finally, we can use that quadratic formula. So remember, the quadratic formula is x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I'm not going to have you memorize this formula. I'll always give it to you, but it's nice to have memorized if you ever need to use it in another class. And then there's actually a 4th way to solve this equation, which might be sort of the modern technique, which is using technology. So we're going to do it like that too. So take a look at your handout, which looks like what? Looks like this. And so take a look at this handout. We have this equation, x squared minus 2x minus 15 is equal to 0. And we want to solve this quadratic equation using the given method. So the first method is simply factoring. So let's copy down the equation again, x squared minus 2x minus 15 equal to 0. And factoring is probably the simplest way to solve a quadratic equation. The only problem with it, it doesn't always work. But if it does work, it's pretty easy to do. So the idea of factoring is you know that this should be written as x plus or minus something times x plus or minus something equal to 0. And the something depends upon the 15. And so we've done this before. You look for factors of 15. So when I think of 15, hopefully you think of 3 and 5. So I'm guessing I'll put a 3 here and a 5 here. And then all I have to do is figure out how can I turn a 3 into 5 by adding and subtracting and turn it into a negative 2. So I can add 3 and take away 5, and that gives me a negative 2 there. So if you multiply this out, you'll get exactly this back. But what you have now is this times that is equal to 0. So if you multiply two things together and get 0, you know either this is 0, so either x plus 3 is 0, or x minus 5 is 0. So this is a property of multiplying real numbers. If you take two numbers and you multiply them together and get 0, one of those numbers has to be 0. So then you subtract 3 from both sides, you get x equal to negative 3. You add 5 to both sides and get x equal to 5. All right, so that's sort of nice and easy to do once you get the hang of it. Now remember, this technique doesn't always work. So if you come up with a different equation like x squared plus 5x plus 1 equals 0, you may not be able to factor this because the roots may not be nice, right? These are nice roots, negative 3 and 5. These roots might be square roots. They might even be complex or imaginary numbers. So you can't do it to all of them, but when you can do it, it's nice and easy. It's the easiest technique to use. Let's do completing the square now. So for completing the square, let's copy down the equation again, x squared minus 2x minus 15 equals 0. And remember, for completing the square, what you're going to do is you're going to add half the middle term squared here. So I have x squared minus 2x. Of course, the middle term is negative 2, so you take half of it and square it. So half of negative 2 is negative 1, and you square it, so that's positive 1. So you'll add 1 and take away 1 right next to it. And I don't want to write equals there. So I add 1 and take away 1 right next to it. And you still have the minus 15, so that's important, equal to 0. And then the way this works is if you look at this thing right here, this is a complete square. You can rewrite this as x minus 1, because that's a minus, quantity squared. And then you still have those two numbers on the end, minus 1 minus 15, which is minus 16. And that's still equal to 0. That's 0 there. And so you add, remember you add half the middle term squared. Half the middle term squared. All right, so if you do this, you get this equation, which is really the same as the last, but it's written in a slightly different form. It's written in a form that if you move the 16 over, so we add 16 to both sides, something really nice is going to happen. So what's going to happen here is you just get x minus 1 quantity squared on the left and 16 on the right, and you can undo the square by taking the square root. So you take the square root of both sides, so you have x minus 1 on the left, equal to, and then remember, when you take the square root, it's plus or minus the square root of 16. All right, so you just square root both sides, that undoes the square, and you put plus or minus root 16 on the right. And then, of course, this is x minus 1 equal to plus or minus 4, because square root of 16 is 4. And then we'll add 1 to both sides, and we'll get x equal to 1 plus or minus 4, which leads, again, to two answers, 1 plus 4, which is equal to 5, but let's get rid of this. I don't want that there. So my first answer would be 5. If you do 1 plus 4, and then 1 minus 4 is negative 3. And of course, the answers are exactly the same because you're solving exactly the same equation, but it's another way to solve it. Of course, it's a lot harder, but this technique you can actually apply to this problem here. I'm not going to do it, but it's good to know that factoring won't work on this, but completing the square actually will. And it's a good exercise to try if you're interested. Okay, what's next? So we have completing the square, and then we have the quadratic formula. So the quadratic formula is another way to solve this equation. So we have, again, x squared minus 2x minus 15 equal to 0. For the quadratic formula, it's simply a formula, x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we have to identify a, b, and c. Now, to find a, b, and c, what's happening here is it's coming from the standard form, ax squared plus bx plus c, and the equation, of course, is 0. Equal to 0. So a, in our case, there's just a 1 here, so a would be equal to 1. B, which is the second term, the term on x, the coefficient on x, which is negative 2. And then c, which is this negative 15. And you simply plug and chug. So x will be equal to negative b, so it's a negative negative 2, so that's positive 2, plus or minus the square root of negative 2 squared, so that's 4, minus 2 times a, so 2 times 1, times c. Now c is negative 15, so let's write negative 15 there. And then all over what? All over 2 times a, so 2 times 1. And so this is equal to what? So you have 2 plus or minus the square root, and here you have 4, and then that's what, 30? Oh, I made a mistake here, right? So this is actually, that's not a 2. That's supposed to be a 4. That was my mistake. Okay, so this should be 4, and then minus a negative is a positive, so plus, and 4 times 15 is 60 all over 2. And so that's equal to, you just keep on sort of grinding this out. So 2 plus or minus the square root of 64 all over 2, which equals 2 plus or minus the square root of 64 is a nice number. It's 8 all over 2. And so we're going to get two answers, 2 plus 8, which is 10 divided by 2. And then you get 2 minus 8, which is negative 6 over 2, which then these can be simplified to 5, and of course negative 3. Again, we get the same answers we did before, 5 and negative 3, because we're solving exactly the same equation, but we're doing it another way. We're doing it with what's called the quadratic formula. What's good to know is that actually the quadratic formula comes from completing the square on this equation. We're not going to do it because it's a bit complicated, but it's also a nice exercise. You can Google quadratic formula completing the square, and you'll see how this actually works. Right. So although completing the square is obviously the most difficult way to solve this equation, it's actually one of the most important ways because it's where the quadratic formula actually comes from. Right? The reason the quadratic formula actually looks like this is because of this technique of completing the square. All right, so you should be able to solve a simple quadratic equation like this by either factoring or completing the square or using the quadratic formula, and then also using technology, which is really nice to check our work. So if you have x squared minus 2x minus 15 equal to 0, and you want to solve this with technology, what you would do is take out your calculator and type in the equation, so hit y equals, and then you hit x raised to the 2, and then over, and then minus 2x, so minus 2x, and then minus 15. You can hit your window button, but for my window button, I'm going to do a standard window, which means go from negative 10 to 10. So if you just hit zoom and go down to number 6, which is Z standard, it's just a standard window, so I just hit 6. You get a nice looking window that goes from negative 10 to 10. Now you can't see the actual vertex because it's actually below here, but all I care about are these roots right here. So if you want to find those zeros, okay, those are actually zeros because the equation set equal to 0. So look what I'm saying here. So the equation is equal to 0. So what you're looking for are the zeros. So you're looking for when it crosses the x-axis because that's when the output is 0. And so you can show some work by simply kind of copying down the graph. It doesn't have to be perfect, you know, so it's kind of like, oh, here's the graph. It goes down and it comes up. Right? That's good enough. You're looking for when the height is 0, you're looking for these points right here. And so if you look on your calculator and you hit second trace to get the calculate menu, you'll see there's actually a 0 button. So you go down or hit number 2 and hit enter, and it'll help you find the 0. So right now it says look for a left bound, and this thing is so slow, but you see my cursor here, so I want to move it to the left of the 0. So now here's a 0. The cursor is definitely to the left, so you can hit enter. And then I want to move it to the right, so that passes the 0. Now it's definitely on the right. Enter. Then hit a guess and enter, and it's going to spit out the answer. So x is negative 3 when y is 0. So on my paper here, I might write, you know, I hit the 0 button. So I always like to say, you know, what button I hit. So I'm going to use the 0 button basically. And it tells me x is equal to negative 3. That's one answer. And then the next answer, you have to do exactly the same thing again. So hit second, trace, and then go down to 0 and hit enter. But now this time, you need to get to the left of this 0. So there are all kinds of ways to do this. So you could actually hit 0. So it says x equals 0. So here's x equals 0. That's definitely to the left. So I'll hit enter. And then right bound. So instead of scrolling, I'm just going to go over here. I can count these off. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is definitely to the right. So input of 10, x equal 10 is definitely to the right. And then you just hit enter again, and it'll jump to that 0. So x equal to 5. Right? So x is 5 when y is 0. So when the input is 5, the output is 0, basically. And so I can write down here x equal to 5. Right, so it's very easy with technology as long as you know where to look. So those are the 4 ways of solving quadratic equations. Hopefully you can kind of see why each one may be better than the other, right? Factoring is nice because it's very simple to do. Completing the square is very difficult, but it's what actually gives us the quadratic formula and can be applied to any quadratic equation. The quadratic formula is nice. You may not know where the formula comes from, but you can use it to find the roots. And certainly technology, what's nice about the technology aspect is that this works for any equation, whether it be quadratic, whether it be linear or cubic if it has degree 3, or quartic if it has degree 4. You can use this type of method on any type of equation. Okay, so that's solving equations with quadratics. The next thing we want to look at are solving word problems that involve quadratic functions. So let's take a look at this problem. Suppose there's an open box is to be made from a square sheet. So you have a square sheet of cardboard by cutting out 4-inch squares from each corner. So here's your cardboard sheet here, and you're cutting out these 4-inch squares. So maybe we should label those squares because they didn't label them for us. So these are 4 inches. All right, so 4 inches on, they're little squares too. So each side is 4 inches. And you can label the bottom also, but I'm not going to do that. All right, so you label each of these. Well, maybe I will. So 4 inches, 4 inches, and so on. Okay. And then folding along the dotted line. So when you fold along these dotted lines, you get this resulting box. If the box is to have a volume of 36 cubic inches, find the original dimensions of the sheet of cardboard. So the volume here, let's write this down, is equal to 36 inches cubed. And you want to find the dimensions of the cardboard. All right, so this is my picture. So basically, remember when you're doing your picture, you try to draw the picture of what's happening, which they give us, label the pieces, which they label the dimensions here, x and x, because it's a square piece of cardboard. They didn't label the 4 inches, so I put those in there, and then I wrote down the volume, and then most important, what are you trying to find? Find the dimensions of the cardboard. So for my equation, right, so to find the dimensions, I want to find basically x. So to find x, I need to find a formula involving x. So the only number that's given to me is this 36, which is the volume. So what I can do is write down 36 equals, right, and now this is the volume, so I need to find a formula for the volume. Now remember, the volume of a box, if you haven't done this in a while, maybe you forgot, the volume of a box is the length times the width times the height. So now here's our box, here's our length. Let's say this is our width, and then this is our height. And so if you want, you can write this down, length times width times height. But there's no x, right? So we have to figure out, how can we turn the length, the width, and the height into x? And what you need to do is think about how the sides of the box correlate to the sides of this paper here. So like this is the length right here. Where does that come from? Well, that comes from right here. That's the length, okay? And if you look at this whole length is x, and then this length is 4, and this length is 4, and so how can you make the green length from the whole length and then these little pieces, right? So basically you take x, and you take out 4, and take out 4, and you get the green length. So this is going to be the same thing as x minus 2 4s, so minus 8. And then if you think about the width, let's color that in purple. So here's that width over here. That's this side. Okay. It's also the whole thing here is x, and you're taking out 4 and 4. So that's also x minus 8. And then finally that height, where does that height come from? So where does this h, where does that height come from for the paper? And you'll see that comes from right basically here. And that's just that 4 inches. So h is equal to 4. And so now it's just really a plug and chug problem. So what you have is x minus 8 times x minus 8, right, times the height, which is 4. So my equation becomes 36 equal to x minus 8 times x minus 8 all times 4. And now we want to solve. Now this is a quadratic equation. You have lots of choices to solve. You can multiply out here and move all the terms over to one side. And let's just do that for fun. In fact, right, just for fun, let's just show that this is clearly a quadratic equation. So you have 36 equal to, you would multiply this out, so x times this and x times that. So you have x squared minus 8x. Then negative 8 times x, so negative 8x, and then negative 8 times negative 8, which is positive 64. And this is all times 4. So what we have here then is 36 equal to x squared minus 16x, and then plus 64, all times 4. And now instead of multiplying through by 4, I think I'll divide both sides by 4. That way I don't have to do multiply each of those terms. So divide everything by 4, and you get 9 equal to x squared minus 16x plus 64. And you can move over the 9 to see that, yes, this is indeed this quadratic equation. So you get 0 here, and you get x squared minus 64, or minus 16x, and then plus 55. All right, so you have 4 choices. You can factor, which I believe you can factor this one. If you think about this, you know, 5, this is actually 5 times 11, and a 5 and 11 you can turn into a 16, so you could probably factor it. You could certainly complete the square, you could use a quadratic formula, or you could use technology when you solve this. I'm going to use technology because it is the simplest way to do it. In fact, I could have used technology right here, and that's what I'm going to do. Right, because that's the simplest way to do this. So you can use technology. All right, so let's take out our technology, take out your calculator, hit y equals. Let's just move this over a bit so I can see the equation. And I can just hit, on one side I have a formula, so I'm going to copy down the formula, left parenthesis, x minus 8, in parenthesis, left parenthesis, x minus 8, in parenthesis, and then I have a 4. So put a 4. And then enter, and then I have 36. Right, so I'm going to graph the left, graph the right. I'm going to go to my window. Now here on my window, I'm probably not going to do negative 10 to 10 because this is an actual problem. So x is the length of a cardboard box. So I'm going to start at 0. And I'm going to go up to, I don't know, I can do 10 inches. So let's just do 10 inches, okay, and see what happens. Then do zoom. I'm going to hit 0 for zoom fit, and I get a nice graph that goes down and comes up, and I see where it crosses. But now, hold on. You see it crosses at one point. Look, it's going to come back up. It's actually going to cross at 2 points. So maybe I should make my window a little bit bigger. So let's go from 0 to 20 and then rezoom fit it so I can see where it crosses at the 2 points. So there's the 2 points where it crosses. I might draw a little bit of a picture of this, right, so I can illustrate what's actually happening with my technology. So here, it goes down, it comes up, it crosses, and I want to find where it crosses. So on this one, instead of finding the zeros, I'm going to do intersect. Right, now remember, I used this equation. If you use this equation here, you can do just the 0. So I want to find where it crosses here and here. So you're going to find 2 x values. So on my calculator, I hit second, trace, and then I hit intersect, number 5. First curve, second curve, and I'm just going to hit enter because it'll jump to one of them. So it looks like it jumped over here, x equal to 11. So I'm going to write that down. X is equal to 11 inches. And then I'm going to do the next one, which will give me another x value. So x is equal to, so let's second trace again. I'm going to hit intersect. But this time, I'm going to put for my, first curve, second curve. That's good. First curve, second curve. And then give it a guess. I'm just going to scroll over to it. Right, now yours will scroll a lot faster than mine will. All right, so just scroll over. And as soon as you get kind of close to it, at least further away from the other one, hit enter and it'll jump right to it. And so x equal to 5. So right here, I'll put x equal to 5 inches. All right, so you actually get 2 answers, but one of the answers does not work. So if you think about x equal to 5, this won't work because if x was equal to 5 inches and you went 4 inches on one side and 4 inches on the other, you're going to cross, right? So this is an answer that doesn't make sense, right? So if this was 5 inches and then you try to go 4 inches on each side, you're going to cross. Right? If you go 4 inches here, you only have 1 inch left, and you go 4 inches back over there, you cross, and so you can't get a box. So this is just an answer that does not make sense to our problem. So there's actually just one true solution, and that's x equal to 11 inches. So you can circle that, or if you want, you can write 11 by 11 inches and put a square around that. It doesn't matter to me which one, but it did ask for the dimension, so it's actually 11 by 11 inch square piece of cardboard. And so that's the idea of solving this type of problem. You can test your solution by plugging 11 back into here to make sure you do get out 36, and you will. Okay, the last problem we're going to do, I noticed on this one it's a little bit hard because they don't give us anything, just the words. So let's read through it. A farmer decides to enclose a rectangular garden. So you have a rectangular garden with 600 feet of fence using the side of a barn as one side of the garden. So you're going to use the side of the barn for one side of the garden. You want to find the maximum area of the garden. So once I read through it, I need to draw a picture. And so in my picture, I have a barn. So here's my barn over here. That's my barn. And I'm going to make a rectangular garden on one of its sides. So let's draw a rectangular garden. And I have 600 feet of fence. Now, 600 feet of fence, that's the amount of fence. We call that the perimeter. Right, that's the perimeter of fence that you need. So 600 feet of fence. You're going to use one side at the barn, so you don't need fence along here because you have a barn. So you just need fence along these three sides. So let's label these. Let's label this X and label this Y. We label this X because it's horizontal and this Y because it's vertical. And we want to find the maximum area. All right, so to find the maximum area, we need to find a formula for the area. So A equals. Right, so to find the formula for the area, well, what's the area? It's this shaded region right here. And you find area by taking what times what? Length times width. And so let's write down the formula. This is equal to x times y. Right, length times width, so x times y. And what we want to do to solve this is we would like to graph the area function. The problem, though, is that you can't graph the area function because you have x and y. So that's where this number comes in, 600. So the perimeter of our fence, the amount of fence that we have, is 600 feet. What does that mean? That means if you take these three sides and add them together, you should get 600. So think about perimeter. We talked about this before, but the perimeter is a word we use. You walk the perimeter of the park. It means you walk the distance around the park. So you simply add these three things together. So x plus y plus x. So you have two x's plus one y. And that's 600. And you can solve this for y by taking away 2x from each side. And so you get 600 minus 2x is the same thing, is equal to y. And so now what we can do is we can take this thing and replace it with this thing because they're exactly the same. And so what we have is that a is equal to x times 600 minus 2x. Okay, so you just plug y in to there. Let's erase this piece. And so now we have a formula for the area. It is a quadratic formula. You'll see if you multiply this out, you get 600x minus 2x squared. So it is a quadratic function. And so we have lots of choices here. We can use the technology, which is what I'm going to do, because basically to find the maximum area, you're looking for the vertex of this parabola. So if you wanted to, you could complete the square, right, and write it in vertex form, and then read off the vertex, and that'll tell you basically the maximum area. But we're going to use technology because it's a little bit easier to do, and it's nice because you can see it. Right? So we'll use technology here to do this. Okay. So what are we going to do now? All right, so take out your calculators. And let's graph this. So hit y equals. Let's clear out what we have before. And we can graph this thing. So let's go up here. You can either graph this one or that one. It's the same thing. I'm going to graph the original because it's what I first had. So it's the easiest thing to probably plug in. So I just hit x, left parenthesis, 600 minus 2x, in parenthesis. I hit enter, and that's all I'm going to graph, right? So I'm just graphing the function itself. I'm going to hit my window button. And then I'm going to start at 0 because this is actually a fence. So that says that basically there's 0 feet of fence. And I'm going to go up to, I don't know how many feet, probably a lot because you have 600 feet of fence. So I would actually go up to, maybe I try 100 or 200 or 300. 300 turns out to be the best one to look at. That's because if this is 300, then this is 300, and this is 0, so you get 600 feedback. But you can kind of guess and check if you want. Then I'll do zoom, zoom fit, and you'll see I get a nice looking graph that goes up and comes down, which is important because I'm looking for the maximum. And so there's the maximum right there. Let's copy this down. All right, so when I used my technology, I went from 0 to 300. It went up and comes down. I'm looking for this point right up here. And so what's nice about your calculator, if you hit second trace, it not only has an intersect button and a 0 button, it has a maximum button and a minimum button. Now we're looking for the maximum, so I'm going to scroll down to maximum and hit enter. And then it's going to tell me how to find the maximum. It says left bound, which means go to a little bit to the left of the maximum. So it was actually right on the maximum, but I'm going to go a little bit to the left. So notice my cursor here is a little bit to the left, so I'll hit enter. And then go a little bit to the right. So again, you just hit your cursor, and it goes up to the maximum. And then I want to make sure it goes a little bit to the right. And then hit enter. And then give it a guess, so just hit enter again, and it'll jump right to it. So you get two values. Let's write these down. So it says x is equal to what? So it says x is equal to 150. So this is 150. And this is feet. All right, and then it says y. Now here you have to be careful because their y and your y are not the same. Y is actually the output. So this y right here, that's the output value. It's not the same as our y. Right? Our output here is A. So the area is 45,000. So let's write that down. So A is equal to 45,000 feet squared. So that's actually my actual answer, because remember, they want you to find the maximum area. So make sure you put a rectangle around your answer.